we're hovering above the planet. And therefore, if I have a different collection of notes, as the planet spins to a different degree, I can still label that a B and be accurate, but it no longer lands on a continent. See, it's not contextually helpful for me. If I was to shoot a laser from space to the planet, I would have to know the degree of rotation in order to know when I'm going to hit something, right? But what I really want to do is to note the degree of rotation and then go to the actual planet itself and then use latitude and longitude. See, this would be like playing, the way most people learn the system, it would be like playing Zelda or whatever your favorite video game is that has a map in it, but the grid line that tells you the latitude and longitude of the locations on the map is not on the Earth, it's hovering in space. Therefore, every time you log into the game, the latitudes and longitudes, which are telling you where things are located, are changing because the world is spinning and you're using a grid that's hovering in space. That would not be an easy game to play. That would complicate things beyond measure. It doesn't make any sense. What you want to do is, if you're actually on the planet, which our fingers are on the planet, is to measure latitude and longitude from the planet. And we only use the degrees of rotation to tell us where we are on the planet, right? It just orients us to the location on the planet. Then we no longer use the note names. We use the equivalent of the continent names once our fingers are on the fretboard, which would be the Nashville number system, permanent 1 through 7, or the Greek names. So let's give another example to see what I mean. The 12 points of rotation equal the chromatic note wheel. So picture the Earth viewed from space with a 12-note compass overlying it. So this is the 12 notes. We have 12 notes. That's our degree of rotation. Here's our fretboard mapped out because we have multiple strings on the fretboard, unlike the piano. And this is the continent. We're imagining this is the continent underneath. So that this is us looking at latitude and longitude, but it's not connected to the planet. It's hovering over the planet. The planet is the green space. So then each point represents one of the 12 chromatic notes, A through G sharp. And so that's 12 notes. When you change key, you rotate this wheel, but the internal modal framework, the continents, remain the same. So what happens as the world spins? Well, our fretboard is on top of it. So as the world spins, this shape is moving up. Notice over here that this shape, if I was to measure the distance from E to B, I can say that's a 5, 6, 7, a 7-note away distance. That's great to memorize, but it's not really helpful in context now because although that distance is the same, it doesn't really help me in the context of the continents as they're currently positioned. And in Western music, we're always working on 7-note collections that are basically parallel to each other. So the important thing now is not the relationship between E and B, but the relationship between F and C. The important thing now is not the relationship between F and C, but between F sharp and C sharp. See how the important thing is the related continents. The notes, if you memorize all the notes on the fretboard, that could be a good thing to do, but it's really only telling you like where your point of focus should be so that you can locate where the continents are. Once you find the continents, it would be much more optimal not to communicate by note names anymore, but by communicate by the continent names that stay fixed. Let me show you what I mean. This is the same thing.